7.4, partial fractions.
The actual full title of this is partial fraction decomposition.
Here's what this means, because it's kind of important. Like sometimes, like if you don't know why we're doing this, then that's frustrating, right?
Right, I agree.
The idea is, how if you have like two separate fractions, like you get common denominators.
Add them up.
Yeah.
So that would be 3 over 6 plus 2 over 6, Mrs. K. Steve.
And then you get 5 over 6.
Right.
You just combine those fractions. Well, when you do it with algebra and more things that are more complicated, we can still, even with like x's on the bottom, we can still get a common denominator and add them together. But what if we have a fraction and we want to split it up into the smaller fractions?
And I'll tell you where this is going to benefit you is actually next year in your calculus courses, because there comes a time when you have to integrate.
Yep, fancy word.
Fancy word that you'll learn all about next year. And you don't want to integrate 3x minus 4 over x squared minus 2x. I don't want to do that. However,
if you can split it up into
the smaller fractions,
it's way easier.
Super simple, actually. Okay. So this is actually a skill that will come in handy next year for almost all of you.
And really, the longer you go in math, the more it comes up all the time.
It's spoken by the lady who's in graduate school for math.
Absolutely. So here's some general rules, and these may not make a ton of sense, but when you come back to this page while you're working the assignment or during the notes, you should see that these things are checking off. So the degree in the numerator needs to be less than the degree in the denominator. So see how this is an x to the first and this is an x squared? That means we're good to go. If they were the same, or if the top is bigger, we have to start off by using long division to divide things out. And then we'll end up probably having to do partial fraction decomposition later on.
Right.
The first step, actually, after making sure that you don't need to use long division, is to factor the denominator as completely as possible, because that's what's going to give us the denominators.
That'll give you the bottom pieces. And so you're going to have to maybe dig into all your different bags of tricks for factoring out your denominator. But it should factor to something that you would recognize. Like there shouldn't be a square root running around or something like that.
Right. It should be pretty simple algebraic factoring. And we will get sometimes this term, which we ran into at the beginning of the year, this term called irreducible quadratic.
Something like x squared plus 1. Yeah. So if we have x squared plus 1 and I go factor that,
I can't. Yeah. I can't factor that. You shouldn't be able to either.
If you factor it, you've done something incorrect.
And you could put a minus 1 here, and then it would be factorable, but x squared plus 1 you can't factor. This is considered
Listen to me. Go ahead and write this down real quick. X squared plus 1 equals x plus 1 times x plus 1. Okay, if you write this down, a puppy dies. Because it's not true.
This is what it equals.
That's what that equals.
Not the same thing.
That's not the same thing. Okay, we don't want to kill puppies today.
No. So when you get to something you can't reduce anymore, it may be a quadratic.
It'll work out.
Fine.
It'll all
we'll
work
deal
out.
With it.
Okay.
Each factor will be in the denominator of a partial fraction. All numerators in the partial need to be 1 degree less than the denominator. We'll show you what that means. You can check by graphing if you take what you originally have. So if you take this, and that's like y1, and then you take this and graph it as y2, they should be the same graph.
Like identical. And you can even check that in the table of points. They shouldn't even be close. They should be the same.
Right. So how about we get started?
Let's do. I like that plan.
Okay, so example 1, we're not even going to solve this. We're just going to set up our partial fraction decomposition.
Okay.
So what that looks like is that we take this denominator and we break it up into parts.
There's 3 parts because there's 3 things.
Right. But it's a little trickier than that because
the x cubed.
The x is cubed.
Yes.
So what you do is this factor at the beginning is x.
Right.
Okay, and
x cubed factors.
We have that 3 times.
Right. So you have to actually write down the factors of x cubed, and that can be a toughie to try and remember.
Whenever that happens, that you have something to a power, you end up you have to write the factor, and then you have to write
the next power
squared, and then
the final.
Okay, and that part's kind of tricky, and we'll come back and we'll have that happen again later. So you'll see it again. Our next factor is x plus 3.
Right. That's easy to see.
And our next one is x squared plus 1.
Which is an irreducible quadratic, so it's okay.
Yeah. Now, the rule is that on top here, we're going to put variables, and it has to be 1 degree less than the factor we're talking about. So this x means that we won't have an x on top. That's 1 degree less.
Right.
We need something to represent a number. So typically we go in alphabetical order.
Right. Just start with A. Right.
This,
and use capital letters too, because
that's just
it's easier to distinguish. Like if you have an X and a Y running around at some point, capital letters are easy to distinguish.
Right. X squared is also going to get a letter, okay? Because it's X and it's to some power. So
right.
And then X cubed is going to get a letter.
Those are right. But again, because it's not an irreducible quadratic.
Right. And then X plus 3, that's linear. So
he just gets 1 letter.
X squared plus 1 is a quadratic, which means we need something linear on top.
Right. So
linear,
one degree less.
Yeah. Linear means we have an X. So what we're going to do, because I'm just, again, continuing going in alphabetical order, we're going to use EX plus F. Because think about it. What's the equation of a line?
MX plus B.
Right. So we're just going to, and we could use, well, we can't use B, but so EX plus F.
Right.
Now, solving this would be just terrible.
Well, maybe not terrible, but it would require quite a few steps.
Yeah, so this is just us setting it up. You've actually now seen all of the tricks to setting up a partial fraction decomposition. And now after this point, we're actually going to start solving them.
That sounds brilliant.
Okay.